The position of an object is defined by the equation s of t equals 4 sine t I plus 6 cos t j. When t equals 3 radians, what is the magnitude of the object's velocity? So we're getting into some kinematics here, and we have an expression for the position of an object, and it's based on some trigonometric terms, and it's broken into components, so there's an I hat and a j hat, and we've been given a value at which we would like to know the object's velocity, or at least the magnitude of the object's velocity. We don't need to know the direction, so that's helpful to know. So what's the relationship between the position of an object and the velocity of an object? Well, the velocity is the derivative of the position. So that's where we're going to start. We're going to differentiate this thing. We'll say the velocity of t is going to be the derivative of the position of t. So we'll call it s prime of t. And now can we differentiate this expression? Of course we can. So we're going to differentiate with respect to t. The derivative of sine is cosine. So 4 cos t, and that's still times the vector I. I'll use the hat symbol here. They use bold in the reference handbook and a lot of the solution guides that you'll find. I don't have a way of creating bold on the fly here when I'm writing, so I'll go back to the old school vector notation here. I'll use I hat and j hat. And then for the j component, it'll be minus 6 sine t j hat, because the derivative of cosine is minus sine, and the constant just passes through. So a little bit of a review of some derivatives there. But now we have an expression for the velocity in terms of t, and we're interested in the magnitude of the velocity. So how do we find that? Well, the magnitude doesn't care about the direction, so we can take each of these terms and square them and take the square root of the result, and we don't have to worry about the vector components for this. So it'll just be 4 cos t quantity squared plus minus 6 sine t quantity squared, and it's the square root of that whole thing. Rather than writing a big square root symbol, I'll put it in brackets and raise it to the 1/2 power, which is the same thing. So let's actually do the algebra at least inside the brackets. We can say the magnitude of v is 16 cos squared t plus minus 6 times minus 6, 36 sine squared t, and that all still needs to be under a square root. So that's as simple as we're going to be able to get it in terms of having an expression in terms of t. At this point, the only way forward is to make the substitution and say, if this is a general equation for the magnitude of the velocity in terms of t, but we're interested in, we want to quantify that. We want to actually specify numerically what is the magnitude of the object's velocity at a particular value of t, and that value is 3 radians. Now, if you're comfortable using your calculator in radian mode, you can probably plug this in directly. I prefer to use degree mode, so for my taste, I'm going to change t from 3 radians to a corresponding number of degrees by multiplying by 180 over pi. There's 180 degrees for every pi radians, so you can make that multiplication, and I'll get 540 over pi. That's the value of t in degrees. So it's 3 radians is 540 over pi degrees, and that's what I'm going to plug into the calculator. So the magnitude of v when t equals 540 over pi is 16 times, and now we need to be a little bit careful with our grouping symbols because we're going to write some interesting nested algebra here. Cosine, I'll use parentheses here, 540 over pi, and then I'm going to square it outside of all that. This just makes it more clear when you're putting it in your calculator. It's not wrong to write cosine squared and put the squared here, but I just think it can be a little tricky and lead to mistakes sometimes, so I'm being extra cautious with the algebra. 36 sine 540 over pi, and that's squared, and then I'm going to use really big grouping symbols out here. I'll put braces, and that's all being raised to the 1/2. So just be careful. You can do this in steps in your calculator. You can calculate this first. I actually took the time to do that, so I got approximately 15.681 for this first bit plus 0.717, and that's all inside the braces. That's being raised to the 1/2, and the result is 4.05. And the units for velocity are going to be radians per second. Even though we made the substitution in degrees, all the units go away. We just have to think about what we mean in terms of the motion. So this is either oscillatory or circular motion. So that's why it's radians per second. And in any case, you don't have to get too caught up in that because all the answer choices are radians per second. So as long as you get the main idea here, which is position function, differentiate it to get a velocity function, and then square the components and take the square root to get the magnitude of the velocity and make the substitution, then you're going to find your way to answer choice D.